Good morning to you all. In the today's class, we are going to discuss the next topic of Java, that is interfaces. So interfaces are syntactically similar to the classes, but they lack in one thing, and that is instance variable. So the first difference of instances from classes is you can't instantiate an interface. Interfaces are, in other words, we can say these are stateless. They can't keep record of the state. So in interfaces, we generally declares the method. We need not write the definition of the methods, and by default, the methods that you define declare in an interface is public by default, and the variables that you declare in the interface are static and public, and also final by default. So we will discuss about these features of interfaces in more detail with examples. So here is the general form of declaring an interface in a Java program. So first you need to write an access modifier that we discussed, that the Java provides us three access modifiers: static, public, protected, and private. So if you don't write any access, that means that interface will have default access and it will be accessible publicly in the same package. So the rules that we have already discussed applies to interfaces also, with respect to the access of the interface, whether you have created a default access interface or a private interface, protected interface. Then within the braces, two kinds of members you can declare in an interface. The first is the methods. So in case of methods, as we discussed earlier, in interfaces we just declare the methods. So first you have to write the return type of the method, then name of the method, and after that within parentheses you can write the parameters, a list of parameters. The second type of members that you can declare in an interface is a variable. And as we discussed, that a variable that you declare in an interface are by default of final type. So these are basically constants and their value cannot be changed. So this general form says that the final variable should have some type, integer, float, double, long, or any other data type that Java supports. And after that, the final variable name, and then equal to, and after that its value. So this is the general format of the interface. So the interface, I repeat, the variables are by default final and static. So, and the methods are public by default. To implement the interface, the class that implements the interface must define all the members that are there in the interface. So when a class extends an interface, we use another keyword implements. So if a class is extended from another class, then we use the keyword extends. And if the class inherits the properties of an interface, then we use the keyword implements. So a class that implements an interface must define all the methods of the interface. Although the partial implementation of the interface is also valid, what will happen in that case, that we will discuss very soon. So here is the general format. If you are implementing a class from interface, first you will write the keyword class, then the class name, after that the keyword implements, and then the interface name. So this general form suggests that the class can implement more than one interfaces as well. If you are implementing more than one interfaces in a class, then in this syntax you have to write all the interface names separated by commas. So here is the first example based on the interface. So in this case we have created one interface with keyword interface, and then the name of the interface is callback. And in this interface we have one method, that is callback. Its return type is void and it has one parameter of type integer. Here the definition of the interface ends at this place. Then we have class that is implementing this interface callback. So the syntax that we have to follow is class and the class name, the client name of the class is client. Then the keyword implements. After that, the name of the interface, that is callback. Then within the braces of this class or within the body of the class, you have to implement, you have to define all the methods of the interface, as there is only one method callback. So your class client should implement the definition of the callback. So here we are implementing the callback. So please note that because the methods of the interface are public by default, so when you will define the methods in the class, you have to add the access specifier public before the signature of the method. So that's why we have written public over here. So this is mandatory, you have to write public. And this parameter you can skip, you can just write int. Okay, this variable is not required when you declare the interface. Or even I have used two different names over here, so this is also valid. So in this case, in this definition of the callback, we have written over here callback called with the p. So we are printing the parameter p that we will pass to this method. So this is the implementation of the callback method. Then if you want to use it, so we will create a reference of the interface type callback. So that's why we are using over here callback C. Then to the right of this, we are creating an object of the client class with a new keyword, new client. This object of the client class will be given a reference C. So this is another important point. If you have interface in your program, Java program, and one class implements the interface, then that class methods can be called with the interface name. So this is the object of the client class, and we are assigning it to a reference that is of type interface. Right? So if a class implements interface, then that interface reference can refer to the object of the, the class that is implementing the interface. So with the interface reference, we are calling the method callback. So this will call this class method callback. This 42 will be passed as a parameter to p, and then the definition of the callback method will run, and you will get callback called with p, and here you will get the result 42. So the important point is you can create the object of the class and give it the reference that is of type interface. Here is another example. In this example, the class is adding its own functionality also. So we have the same interface callback, and I haven't shown that callback interface over here. So we have created the client class, and it is implementing the callback interface that we discussed on the previous slide. And this class client, it must add the definition of all the methods. So definition of callback is there, that is declared in the interface, and the class has added some more functionality of its own. So this is the functionality that the class has on its own. So the important point over here is, if we are implementing an interface in a class, in that case the class should define all the methods that are there in the interface, and the class can also add its own methods or variables. So this is the important point over here. Now the class has added a non-interface method, this one. And how you will call this? Again, in main, we are creating the object of the client class, and we are assigning it a reference, and the reference is of type interface callback. Now in this class we have two methods. One is callback, that is the implementation of interface method, and other is non-interface method that a class has added of its own. You can call the callback with the reference of interface type, but with this C, you can't call non-interface methods, that is the methods that are not declared in the interface, or the method that the class has added on its own. So these methods cannot be called with the interface. So if you try to execute c dot non-interface method, you will get the error message, right? So the non-interface method, or the methods that don't belong to the interface, cannot be called with the reference of the interface type. So if you want to call now the non-interface method, you have to create the object of the client class, and the reference should also be of the client class type, right? So this is how you can call the method of the client class. Here is the another example. So we have one interface. Its name is again the same, callback, and there is one method that is declared in it, callback. Again, the name is same, and we are implementing this method and creating a new class client. This is the method callback, and next in this example we have another class, and the class name is another client. It is also implementing the same interface callback. So in another class also you have to write the definition of the callback method. So this we have done over here. So this is the definition of the callback method in the second class. Then in the main we are creating the object of the client class and assigning it to the reference of type callback. And in the next line we created another object of the second class that is of another client class type. So we called first the callback method of the first class with the reference to the interface. So this will call this method callback, and you will get callback called with p42. Then we are assigning the reference of another object to C, because C is interface that is implemented by both the classes. So you can assign the object of the second class to the reference of callback interface type. So now if you call c.callback, it will call this method, the second method of the another client class, and 42 will be passed as a parameter, and with this you will get another version of callback p squared 42 into 42. This you will get on your screen. So the important point over here is it's performing dynamic dispatch of methods that we discussed earlier in inheritance as well. So we have two classes over here. We have object of two classes. One object is of type client, other object is of uh, class another client, and there is a reference to interface C, and C is implemented by both the classes. So you can keep the reference of the first object in C, or you can keep the reference of the second object in C. If in C we have reference of first class, and if you call the callback, it will invoke the callback of the first class if the reference of first object is there in C. If the reference of second object is there in C, and if you write this statement c.callback, then it will call or invoke the method of the second class. So here it performs a dynamic dispatch of method at runtime if the reference of interface type is referring to the first class, the method of the first class will be called. If it is referring to the object of the second class, then the method of the second class will get called. So this is example of runtime polymorphism, or we can say this is a dynamic dispatch of methods. Here is another example on interfaces. So it's not mandatory to implement all the methods of the interface in a class that is implementing it. You can partially implement the interface also, but in that case, if you want to implement the methods of the interface partially, you have to create a class of type abstract. Then only this is possible. So as in this example, we are partially implementing callback. So as we discussed earlier, there is one method in the callback interface, and that method name is callback in small, right? And interface name is callback, and C is capital. So Java is case sensitive, so this is possible. Uh, Here, this incomplete class is not implementing the method that we declared in callback. That is again the callback with small c, right? So this is the partial implementation because this class is not implementing the methods. Or if there are, let's say, 4 methods in the interface that you have declared, and this class is defining just 2 out of those 4, that means it is partially implementing that interface, right? So here, because only one method is declared in it, and that method is not defined in this incomplete class, that means it is partially implementing the class. In the class, we have added one method, uh, show, right? So this is possible only if we create the class of type abstract. And as we discussed earlier, the abstract class cannot be instantiated. We cannot create the object of the class. So now, if you need to use this incomplete class, you have to extend it, because abstract class cannot be instantiated. You have to extend this class incomplete and implement the callback method there. So if you are not implementing the method of an interface, then the object of the class cannot be created, as we discussed earlier. So here is another topic on interfaces, that is a nested interface. So you can declare an interface within another interface. So interface that is declared inside another interface is called member interface, or it is called nested interface. The nested interface can have any access specifier, public, private, or protected. So another important point about the nested is, when a nested interface is used outside its enclosing scope, means outside the interface in which it is declared, it must be qualified by the name of the interface or the name of the class in which it is declared. So we'll discuss this point with one example to make it clear. So we have in this case uh, a class A, and in this class we have one interface. See here, this is the interface. Interface name is nested IF, nested interface, and it's of type public. This is the definition of the interface that I am drawing a boundary around. And it is nested in a class. It's a member of a class. So this is a member interface because it's a member of a class, or we can call it nested interface. Then we have one class that is implementing the nested interface. So we are writing over here class B. It's implementing the nested interface. So you have to write the fully qualified name of the nested interface. So A is the class name of which it is a member. So class name is first dot. Then the nested interface name. This is the nested if. So this B class is implementing the nested interface, nested if of class A. And in this class, we have defined this method is not negative. So we have defined it is not negative, and in it we are checking if x is less than 0, then it will return false, and if x is greater than or equal to 0, then it will return true. So this is the definition of the is not negative. Now how we can use it? So as we discussed earlier, if you create the object of a class that is implementing interface, over here we are creating the object of B class, then that object can be referred by a reference of type interface. So this is the interface fully qualified name. A is the class name whose member this is. So nested interface is the name of the interface, and this is creating the variable or reference of type nested interface. So NIF is the nested interface. So this is reference of the object of type B. Then we are calling with the NIF the method that we have defined in the class is not negative. So this is not negative will be called with the value 10. So this will be passed on to the variable x. X is 10. 10 less than 0 is false, so it will return true. So is not negative will return true. So you will get 10 is not negative. You will get this message. If I pass a negative number from here, let's say minus 10, right? So in that case, this minus x, x will be minus 10. Minus 10 less than 0 is true. So if it is true, this will return false. This will go here, false. And if false, we will get the else part, right? So here we are showing that it's not negative. With it, this wouldn't be displayed, because in that case this condition will evaluate to false and you will not get this message. Otherwise you can write else part of this if statement over here and print some message that the number is negative. That will be better. Then the next example is, so this is the case of nested interface we discussed this slide. The next slide is, now we have a nested interface that is defined inside another interface. So in the previous example, we nested an interface within a class. Now we are nesting an interface within another interface. So the outer interface name is showable. So in showable interface, we declared one method show of return type void, and in the showable interface, there is another interface. Its name is message. And in message interface, we have a method msg of type void. And when you will implement this interface, message interface, how you can do that? So first you have to write the name of the class test. It's implements, because we want to implement the inner interface, nested interface. So you will write first the outer interface name showable dot, then the nested interface name message. So this is the message interface that this class is implementing. Now, in this class, you have to implement the MSG method of the interface that we have declared in interface here. So we are implementing that, right? So public is required. So we have attached the public keyword because by default the methods in an interface are of type public. So in this method, we are displaying the message hello nested interface. So this is what it will display when it will be called. And in the main, we are see have created the object of the test class. This is the test class. So in this we have main as well, and the reference to this is of this interface type showable.message type. This is the name of the reference message, right? And with the interface reference type, you can call the method. So we are calling message dot msg. So message is the name of the reference, and with this we are calling msg method. So this will get called, and you will get hello nested interface on your monitor screen as the result. So in this slide, we are going to discuss how we can use variables in an interface. So we have created one interface named shared constants. And in this interface, we have created some named constants, no with value 0, yes, maybe, later, soon, or never, with values from 0 to 5. And each variable is of type int. As we discussed earlier, if we declare variables in an interface, those variables are static and final by default. So all these are final variables, and final means they are constant, their value cannot be changed later on in the program. So here what we are doing is we are using these named constants in the program as a cases of a switch statement. So I'm going to show you that. So this interface is implemented in a class question, and in this question class we have created a random class object. So random class is basically it's defined in package util, that is sub package of Java. So we are creating the object of that, and then there's a method in of type int ask, right? When it will be called, it will do some job that we will discuss in this part. So in this part we have another class name is ask me, and it's implementing shared constant interface. So in it we have a method static void answer, and when it will be called it will do something. Again, we will discuss this later what it is doing. So this is the main class, main method. So in this method we are creating the object of the question class, and then we are calling this q dot question ask. So this is reference to the object, and when you will call q dot ask, this method will be called. This is the question class, and this ask method will get called. When it will be called, its statements written in it will be executed, and in the body of the ask method we are creating we are basically getting a random number. So this is the reference to the random object rand, and the next level will give you a number between 0 and 1. If you multiply that number with 100, you will get a number between 0 to 100 that we are converting into integer. So this will give you a double number, next double, from 0 to 1, and we are multiplying it with 100. That means we are scaling it from 0 to 100 and then converting that number to integer value. So you will get the integer value over here based on the value of PROB or random number. We are displaying a message. If the value of PROB is less than 30, then it will return no, and the value of no is 0 as we have assigned over here. So this will return basically a 0 value. So here we are using these constants or the interface members, interface variables uh, as the constants of return type in a return statement. So as if the probability is less than 60, we are returning yes, and if the probability value is less than 75, prob value is less than 75, we are returning letter, and so on. So basically we are using these members as constants over here, and then based on the value that this will return, because this ask will return any value from 0 to 5, right, depending upon what is the value of the random number that we get from this random object. And then this inner part, this q.ask, will return any number from 0 to 5 as we discussed, and with that the answer method will be called. So answer is this method. Let me show you this one. This is a answer method. It's a member of a class ask me, and main is also a member of this class ask me, right? So that's why the main can call this answer method directly. So we are calling this answer method directly because main and the answer, these two methods are members of the same class. So one method can call the member of the same class directly. So the main is calling the answer method directly. And we have defined method static because main is static, and the main can call the static members of the same class. So this will get called with any value from 0 to 5. So the result value will be from 0 to 5. It can be 0 or 1 or 2, right? Then we are using it in the switch statement. So based on the value of result, if it is 0, then it will match the no case and you will get no on the screen, and then this break will break the switch statement, or the control will come out of switch. If the result value is maybe, then this case will be executed and you will get maybe on your monitor screen, and so on. So here we have used the constants that are defined in the interface. So this is another use of interface, that if you want number of constants in your program, then you can create those constants within the interface, assign them some values, and you can use those named constant in your program anywhere. So here is the another concept of interfaces. You can extend the interface just like a class can extend another class. Similarly, the interface can extend another interface. So how we can do that? For that, I have shown one example over here. This A is the interface. It has two methods. One is method 1, other is method 2, both are of return type void. And we are extending interface B from interface A, so you have to use interface, then the derived interface name, keyword extends, then the interface in A, and in this B interface we are adding another method, math3. So in B there will be three methods, math1, math2, and math3. So these two methods will get inherited into the B interface. So in a program, if you implement the B interface in a class, you have to provide the definition of of all the three methods, math1, math2, and math3. And if you are implementing the A interface in a class, then you have to provide the definition of the math1 and math2 methods. So here is the example on extending the interfaces. So we have a class, my class, it's implementing B. So because B interface is extended from A, so you have to implement or define all the methods that are in B and that are defined, that are inherited from A as well. So we have defined three methods in this my class. One is math1. This is the definition of math1 method. Then this is the second method, math2, its definition. Then the third method, math3. And this is the end of the class. So to use this class, my class, we have to create the object. So we are creating the object over here, and we are assigning a reference OB to this object that is also of my class. Then with this we are calling math1, math2, and math3. So you will get implement math1, implement math2, implement math3. So this is the case. I think you get it right because this is very easy concept. Then the next is default interface methods. So before JDK 8, interface cannot have the definition of the method. You could just declare the methods in the interface, but after 8, within 8 JDK 8 and the later versions of JDK, you can even write the definitions of the methods in the interface itself. And if you want to write the definition of any method within the method within interface itself, you have to make that method default by using the default keyword. But the basic features of the interfaces will remain the same, that they are stateless. Interfaces are stateless, means we can't create object of the interface type to store the instance of the interface. So here is the example. These are these default methods, as we discussed earlier, are introduced in JDK 8 and in the later versions. They are available in the later versions of Java as well. So here is the default method. See, we have an interface of type public. This is the method that we have just declared, and this is the method that have a definition as well. So method name is getString, it's returning string, and its default method is providing some definition as well. So it has body also. So a method that has body in the interface and defined in the interface are called the default method. So that you will instruct to the Java that this is the default method with the default keyword. And if any class implements the interface that is having default method, then the default method needs not to be overridden. So here is the complete example to make a concept clear. So this we have in here class IF implementation, my interface implementation. It is implementing my IF, right? So this is my IF. The previous slide I have shown you, it has one method get number that is declared and one default method get string. So in here we are what we are doing is we are adding one more. This is get number, right? That we are defining. Uh, this method is overriding the method that is declared in or implementing the method that is declared in the interface, and this method is returning the value 100. So we are implementing basically this method in the class get number, and we haven't overloaded the default method. So keep in mind we haven't overloaded defined default method of the interface over here. Then in the main we are creating the object of the class and assigning it the reference obj, and with obj we are calling get number, so you will get 100 as a result over here. Then we are calling the default method of the interface. So default method will get inherited into this class, my interface class, and if you call that method with the object of the class obj, uh, that method will get called. So when this will get called get string, you will get this message default string. So the important point is if there is a default method in an interface, it's up to you whether you are overriding that method in the class or not. So here we are not overriding. I will show you one more example where we will override the default method of the interface. So here is the next example. So in this example, we have another class, my implementation 2. We are implementing my interface that we discussed on the previous slide, and in this class we are overriding the get string method, right, of the interface. So you can override that to get a different result. So keep in mind that whenever you will override the method of the interface, you have to attach the public access modifier to it. And this time we have changed the string. Now, if when this will be called, we will get this is a different string, right? So if you keep the main method same as that of the previous class, this one, and instead of this class, my ifm, instead of it, if we use this class of the my if imp2, then when you will call the get string method, you will get the this method will get called and you will get the result. This is a different string. So the crux of the concept of the problem is you can override the default method of the interface also in the class, and if you don't want to do that, you can use the default implementation of the method as well. So this is all about the interfaces. Java don't support multiple inheritance. You can't extend a class from two classes, but that in case of interfaces, you can implement, or your class can implement two or more than two interfaces also. So this is all about the concept of interfaces in Java. If you want me to show you some examples on the Eclipse, I can do that. But for that, you have to leave your comments or your questions in the chat window, and I will try to implement those problems on Eclipse as well with you. Going to discuss is exception handling. So exception basically arises when in your code there is some issue at the time of execution. So we can say if there is some runtime error, then the exception condition arises in the Java program. The very simple example of this is if you divide a number by 0, then at the execution time, that will give you the error. So that is called exceptional condition or exception. So whenever the exception condition arises, Java creates the object of that exception type and then throws it. And that exception is then handled by the Java exception handler. Normally, the languages like C doesn't support exception handling, and if a language is not supporting exception handling, in that case you have to check the errors manually, and after checking the exceptions manually or errors manually, you have to write some code to do some task corresponding to that. So in case of Java, because it supports exception handling, when an exception arises in a program, your Java creates the object corresponding to that exception and then throws the object that is created by the Java, and then that object is caught and corresponding block is executed. That is called a exception handling block. So exception handling basically this chapter deals with handling the exception. If any situation, exceptional situation arises in your program, for example, if you inadvertently divide a number by 0, then that will create the exception condition. Or if you are using an array of size 10, so its indices will be from 0 to 9, and if you by mistake use an index of an array greater than 9, then that will not be supported because your array size is 10. So that will also create the exception condition. So such type of conditions, how you can handle those, that we are going to discuss in this chapter, exception handling. So the first important thing is the code that you want to monitor for exceptions, that you will write in the try block. So in case of Java exception handling, Java has provided five keywords that are used to handle the exceptions: try, catch, throws, and finally. One by one, we are going to discuss all these keywords in detail. So the code that you want to monitor for exceptions, that we will write in the try block. So first we will write the keyword try, and then within the braces we write the code that we want to monitor. And then after the try block, there should be a catch block or multiple catch blocks. There shouldn't be any statement in between catch and try, right? So just after the try block, the catch should be there. So you will write the catch, and then within the parenthesis of the catch, you will write an exception type. So this exception type is basically an inbuilt exception class or user defined exception class. After that, the object of that exception class, right? So multiple catch blocks can be there. This we will discuss in the coming slides in detail. And then there can be a finally block. This block is optional. If you write the finally block, that will be executed always, whether there is exception or not. So this is the general format of the exception handling. So I repeat, whenever you want to monitor some code, some statements for exception handling, you will put that block in the try block. And in case of a certain exception, if you want to perform some task, that you will keep in the catch block. So let's discuss it in more detail. So in Java we have one throwable class. This is the superclass of all exceptions. So this class has two subclasses. One is called exception, other is called error. So this is not in our syllabus. This is not we are going to discuss. We are going to discuss this part only, exception. And exception class has one subclass, runtime exception. So the runtime exception is during when you will run the program, during the program execution, if the some logics goes wrong and you get some exception, error condition, and then an object is of this is created. So this we will discuss in the more detail. Here is the first example where we are not catching any exception. So this is the example of uncaught exception. So there is a simple program. So in this program we have d is equal to 0, and if we run this statement, a is equal to 42 by d, during the compilation process you will not get any error, because this is a as a kind of runtime error. So exception handling are basically meant for handling the runtime errors. So this is a runtime error. So when you will run it, here this line will create the exceptional condition, because a number, if you divide that by 0, in that case this will generate a runtime error. And when an exception condition arises, as we discussed earlier, Java creates the object corresponding to the error, because this is a kind of arithmetic exception, because division by 0 is not possible. So here the Java will create the object of type arithmetic exception. Arithmetic exception is an inbuilt class. It is defined in the lang package of Java, right? So this Java is the main package, lang is the sub package, and arithmetic exception is one of the classes that is defined in it. So here the Java will create the object of arithmetic exception class, and then this method main will throw that exception. When an exception is thrown by a method, then an exception handler is executed. The exception handler will start executing, and the exception handler will catch that exception. So in this case, because we are not handling the exception in our method, so Java will run its own exception handler, default exception handler. That exceptional handler, what that does is that exception handler just displays the exception object. So when the Java exception handler, default exception handler will display the object that is created in this method by this line 42 by d. So it will display the arithmetic exception object, and when the arithmetic exception object is displayed by the default exception handler, what you will get the details about where the error condition occurred. So this is basically showing that the exception occurred at line number 4. So this is the line number 4. If you count from this line, this is line number 1, line number 2, 3, and 4. Exception occurred at line number 4 in the main method. So this is the exception in main method. So method name is main, and this main is a part of the exc0 class. So this is the name of the class where the exception has occurred, and this is the detail of the exception. The detail of the exception is the section is of type arithmetic exception, and it is divided by 0 exception. right? So this is the detail that the default uh, exception handler will display. But in this case, the Java's default exception handler is working. So what we want to do is we want to implement our own exception handling code. We want to perform some job corresponding to the error that will occur in the program. So here is the description of that. That way I have already explained to you. So whenever the exception occurs, Java, I repeat that, whenever the exception occurs, Java creates object. So divide by zero error will occur there in the previous slide. So Java will create the object of the arithmetic exception class and will throw it. When the exception is thrown, it is caught by the exception handler, and in that case, because there is no user defined exception handler, so Java default exception handler will run and it will caught the exception that is thrown by the main method, and then that default exception handler will print or display the values that are there in the object, and you will get that description. Now, if I change that the previous program a little bit, if I create a class named this exe1, there is one module subroutine, right? And we are calling this subroutine from the main method. So we are writing over here exe1. This is the class name, and because subroutine is the static method, so you can call it directly with the class name. So that's what we are doing over here. So in this, the exception will occur at this line because the logic is the same. Divide by zero exception will occur. So this time, this line will create the arithmetic exception object, and that will be thrown. And the Java exception handler, default exception handler, will caught that exception and will print that. So when the default exception handler will print that exception, you will get this response on your screen. This time, if you look at this detail, see what it is displaying. Now the error has occurred at line number 7 in the main method. So if you count from here, this is line number 1, 2, 3, 4, 5, 6, and 7. So this is line number 7 in the main where the exception has occurred. And this main is basically has called the subroutine. In the subroutine, the exception occurred at the line number 4. So if you count from here, this is line number 1, 2, 3, 4. So fourth line has generated the error. So it's giving us this output, the arithmetic exception by 0. This is the kind of exception that has occurred, this one. And this exception occurred at line number 4 in the subroutine module or method of exe1 class. And this was called from the main. This method was called from the main, and in main that was called at line number 7. So this kind of detail you will get in case of you are not handling the exception, and your program will come to an end abruptly, right, where the exception will be generated. So how you can handle such kind of exception, we are going to discuss that. So as we discussed earlier, if you want to handle the exceptions on your own, you have to write the code that you want to monitor for exception in the try block. So we have kept in this program those two lines in the try block over here. So in the try block, we have d is equal to 0 and a is equal to 42 remainder day. So this line can generate the error that we have kept in the try block. And after this try block, we have one catch block, and in this we have used this class name arithmetic exception. This is the name of the class, and this is the reference of that. This is a kind of parameter, you can say. So now what will happen when you will compile and run this program? So it will create two integer type variable, then the control will enter into the try block, and in the try block, the first line will initialize d to 0 or assign 0 to value d, and then the next line 42 remainder by d will this will create the exception object. Arithmetic exception object will be created, and that object will be thrown because now this statement is in the try block. So whenever the exception is thrown, your Java uh, matches a catch block that can handle or that can caught the exception object, because here the object created by this matches with the parameter of the very first catch statement. Only one is there, so the object that is thrown by here will pass on to the e variable. So e will start referring to the object that is created by this line, right? So this line will create this object, it will be thrown, and then that object will be passed on to E, right? If there are multiple catch blocks, then a matching catch block will execute. So this E will start referring to this object, and after that the body of the catch block will get executed. So this line will be skipped in this case because exception has generated by this line. So this will be skipped. Here the exception object will be thrown, and the catch block will start executing. In the catch block, you will get this message on your screen. System.out.println will give you this message divided by 0. Fine. And after executing the catch block, the control will be transferred to the next line after the catch statement. So after the catch statement, the next line is this. After a catch statement, this will get printed on your screen. So what uh, result you will get is, because here the exception created, after that this line is skipped, so this message you will not get on your screen. Then after that the catch will execute, so you will get this message division by 0. And because after completion of the catch block, the statements following the catch block will be executed, so you will get after catch statement. So you are going to get this answer as well. So if you have any doubt in the process of this exception handling, you can unmute yourself and ask the doubt. Okay, then nobody is asking that, so I'm continuing. In the next example, we have implemented the same process as we discussed in the previous example, but there is a little change. So in this example, we are again using the random class to generate a random number. In the main, we are using over here I is equal to 0 to I less than 32,000. So this code that we have written in the try class catch block. So this is the end of your for loop. I'm going to draw a boundary around it to make it more clear. So this is your for loop. In this for loop, we have one try block, and this is the end of try catch. I'm going to again draw a boundary around it, and this is the try catch block. So as you can see from this slide, in the body of the for loop there is a try catch block, and after the try catch we are printing the value of a. So what will happen, I'm going to discuss some steps of this uh, example with you. Initially the value of I will be 0, so 0 less than 32,000 will evaluate to true, and when this will evaluate to true, body of the for loop will be executed. In the body of for loop we have a try block. See here, in the try block we have kept some statements that and the statements that we want to monitor. So this will give you r dot next integer. So r is a random class object that we created through this line here. So this will give you a random integer, right? So that you will get in B. And next r dot next int will give you another random integer in variable B, right? So through these two we are going to get a integer number, random integer numbers. And with this what we are doing is we are dividing 12,345 by B by C. So because B and C are both integer type, if the value of B is less than C, in that case B by C will give you 0. And when B by C will become 0, this will create the exception. This line will create the exception. And if B by C is an integer number, when the value of B is larger than the value of C, you will get some integer value. And in that case, this statement will be valid. So whenever B by C evaluates to 0, in that case, this line will generate an exception, divide by 0 exception. And whenever this line will generate the divide by 0 exception, the exception will object will be thrown and that will be caught by this catch statement. In E, we will get the object that is created by this line. And then in the catch block, we are printing division by 0. So this message you will get division by 0. And after that, the value of A will be initialized to 0 by this catch block. When the control will come out of this catch block, you will get A is 0, right? And if this is this condition is this expression doesn't evaluate to 0, B by C doesn't evaluate to 0, this statement will run perfectly fine and you will get some value of A. And when you will get some value of A, in that case, because this statement executed perfectly fine, so that means exception object will not be created. In that case, the catch block will be skipped. So these two statements will be skipped in that case. And after that, after evaluating A over here, control will go to the statement after the catch statement. So this will be executed in that case and you will get the value of A on your monitor screen. So whenever the exception will arise, in that case you are going to get divided by 0 and you will get the value of A is equal to 0. And rest of the cases, the catch block will not be executed and you will simply get the value of A on your monitor screen. The description of an exception. So how you can do that? So the method for that is within the catch block, if you print the object, see here E, because as we discussed in the previous slide, when the exception is thrown, that exception object is passed on to the corresponding matching catch block. So in that case, the E will refer to the exception object, and in this print ln statement or method, we are printing the value of E. So whenever you print the object, the Java automatically calls the toString method of that class. So this toString basically belongs to the object class. And as we discussed in the classes and the object step chapter, that the object class is the super class of all the classes in Java. So each and every class that you will write in Java will be a subclass of object class implicitly. So that means because toString method is defined in the object class, so that means that this object will be there in all the classes. Whether you are writing the standalone user defined class, that will also be implicitly the subclass of the object class, and that will have the toString method as well. So this toString method, when you print this e object over here, then toString method will get called, and toString method prints the general description of the object. Here toString will be called, and that will print the general description. This is the main point. And if you want to customize the message that you should get on the screen, in that case you have to override this toString method in your class. In that case you can get the message whatever you want. So we are displaying the value of e directly using the printf statement, and then we are setting the a. So in this case, what kind of exception we will get? This is the kind that e will print when the toString will be called. It will first print the class name and then by 0. So this is what this message we will get through the e object, and this string exception is there. This will be appended, right? So this the result of the string equivalent of e that you will get through toString method will get concatenated with the exception string, and after the concatenation whatever will be the result, that will get printed. So this is the meaning of this. If you want to display your on, then you on message you have to override the toString method of this object class. Now through this example, we are dealing with the multiple catch clauses. So if you look at this, we have now in the try block, this is the part of the try block. In this we have some statements, and the very first statement is args.length. Args is a command line argument. And this is the array, and you can find its length using the length attribute. And here we are printing the length of a. So it's possible that if you are not passing any command line argument, then in that case the args.length will give you 0. And if you are passing arguments, in that case you will get some length of args. Now we are performing one operation over here, 42 by 0. So this line can generate the error because we are writing 42 by a. The value of e can be 0 if the command line we are not passing command line arguments. So this line will create arithmetic exception class object. And in the next line we have one array, and this array is of size 1. So only one element will be there, and the C of 0 will initialize to 1. So we are basically initializing the array over here. So there is no need to explicitly allocate the memory using the new keyword, because we are performing the array initialization. So in the next line we are using a of 42 because array C size is just 1. So C of 42 cannot be used. So this is a invalid index number. And when the array index is not valid, then in that case another class object is created, and that class name is array index out of bounds exception. So this is the name of the class. So this means that the array Java performs the bound checking on array. Bounds means if the array index is not valid, in that case the Java creates the object of this class array index out of bounds exception. So I would like to remind you, if you look at the name of this class array index out of bounds, it is following the Pascal notation, where the every first letter of every word should be capital. So word array has a capital, word index has I capital, word out has O capital, and so on. So in Java implicitly uses the Pascal notation for naming the classes. That's why the every first character of every word is capital. So in this example, we have multiple catch statement. One catch is having of parameter of type arithmetic exception. Other catch block is having parameter of type array index out of bounds. So when the exception will be generated by this line, in that case the arithmetic exception class object will be created, and then that object will be thrown, and Java will then finds a suitable match class, because in this case the match class will be this catch block arithmetic exception. So in that case this block will run. If the exception is generated by this line, in that case the object of array index out of bounds exception class will be created, and the corresponding catch block that will match this exception is the second one. So in that case the second catch block will be executed. So if we look at this, if we don't pass any argument, then this is creating the exception, and in that case you will get the error message divided by 0 and then the value of e, that we discussed earlier. Then you will get this message java.lang.arithmetic exception divided by 0, so that you are going to get. If this line generates the error, then you will get array index oops and then the value of e, and e will give you java.lang.array index out of bounds exception. So this is the name that this is the error that you are going to get on your screen in the second case, right? And this is the case when you are going to get exception in the first case, because after these two catch statements there is another println statement that you will get, that will get executed always. So in both the cases you are getting the result over here after try catch block and after try catch block. So here's the next problem. So what we have done in this is, in this we have, let's say a is equal to 0 and b is some value, and there is some exception statement. In this example we have two catch statements. One is of type exception and the other is of type arithmetic exception. So when you are using multiple catch statements, you should order the catch blocks in the order of the first there should be the subclass, then the catch should be corresponding to the superclass, because this exception class is a superclass of all the exception classes. So that means this catch block will never be executed whenever the exception will be generated in the try block, because here the arithmetic exception will be generated in this case. So arithmetic exception can be caught in the superclass reference, because as we discussed in the classes and objects chapter, a subclass object can be assigned to a superclass reference. So when this will be created, it will be caught by the first catch block. This is a generic catch block because this has the type exception, so it can catch all type of exceptions. So this will not be executed. The second catch block will not be executed always. So you will get the unreachable code error on your screen. So this will not compile in fact, because when you will try to compile it, this code is not reachable, so this will not compile properly. So in this case, you will get the compile type error. So the main thing, the main point over here is whenever you want to use the multiple catch blocks with a try, you should order the catch blocks in such a order that the superclasses should come at the end. So first there should be the subclasses, and then only you should write the superclass. So next concept that we are going to discuss is nested try block. You can nest a try block within another try block if you want. And in that case, what will happen that we are going to discuss. So the main concept about this nested block is we can nest a try block within another try block. So what will be the syntax of this try block and what rules you should follow, that we are going to discuss with examples to make it more clear. So here is the first example on that, on the nested try block. So in this case, we have one class named nesttry. In the nesttry, we have one main method here. In the main, you have try block. In try block, we are finding the length of the command line argument args. So it can be 0 as we discussed earlier. Then we are performing 42 by a. So this will generate the exception, right? And after that, within this try block over here, we have another try block. So this one is nested try block. So this try block ends over here. And this one, this try block, nested try block ends over here. Let's say this one is the end. This is outside. This brace is outside that. So this is the end of the inner try block. Let me show you by drawing a boundary around it. This one, this bracket is one of the braces is out of this. Let me clear some part of it to make it more clear. So over here, let me draw the boundary again. So this one is outside this, like one of the brackets braces. This is the inner try block. So what will happen? So if you look at the syntax, these catch blocks, this is the one catch block. This corresponds to the inner try block, and here is the end of outer try. This bracket indicates the end of the outer try, this try block, and this catch block belongs to the outer try block. So whenever the exception is thrown by the inner statement that is inside the inner try block. So if we look at this example over here, this line will throw the exception because we are writing C of 42 and the array C size is just 1. In the above line, we have initialized it. If you use this line, this will definitely throw the exception. And when it will throw the exception class object will be created. What kind of object will be created? It depends upon the type of error. The error in this case is the array index out of bounds because the array index is not valid. So that object exception object will be created. Array index out of bounds class object will be created over here by the Java, and then that object will be thrown. And when the Java will try to find a matching catch block, it will find that block over here, this one, array index out of bounds exception. So when it will found that exception block over here, this will get executed and you will get array index out of bounds and E will get printed. This is the case. So the catch of the inner try block is handling the exception. But but one more line is there over this in this try block, and that is this line in this line. So what will happen in this case? What will happen in this line is over here. This line will create another type of exception. So we are finding over here if a is equal to 1, if we are passing just one command line argument, in that case a minus a will be 0, and this line a is equal to a divided by a minus a will create the exception, and this time it will create the divide by 0 exception. So this inner try block has created divide by 0 exception. So divide by 0 exception will create the object of type arithmetic exception. So this line will create for this line the Java will create the exception of type arithmetic exception, and that object will be thrown, and Java will try to find a corresponding matching catch block, and it will look for the corresponding catch block that are attached with the inner try block. So this will not match because the inner try has just the array index out of bound exception type catch block. If the matching catch block is not there in the inner try, then the Java passes that exception object to the outer catch block. So the outer try block has one matching catch block, that is arithmetic exception. So this will catch the exception and you will get the divide by 0 error. So I repeat, whenever there is an exception in the inner try and the created exception object don't have the corresponding catch block in the inner try catch block that you have written, then the catch of the outer try is tested if the outer try is having matching catch block or not. If the outer try is having the matching catch block, then that gets executed. So in this case, I repeat, for this line, if I is equal to a is equal to 1 in this case, because the object created will be of a type arithmetic exception and there is no matching exception block in the inner try, so the exception object will be passed on to the outer try block, and the matching catch of the outer try will get executed and you will get divide by 0 exception. So this is the case of the nested try block. So the next example, this is also the example on nested try, but this is the case of implicitly nested via method calls. So what does it mean? I'm going to show you that first. So in the main over here we have a try block. I'm going to draw a boundary of this try block. This is the boundary of the try block in the main, and we have one method that is there. I'm going to draw the boundary of that method also. This is the method nested try, and this method ends here. This is the end of the method. This one. This is your nested try method. Method name is nest try, and these two method. One is the main method, and is the nest try method. These two methods are the member of the math nest try class. This is defined over here. I'm going to highlight it for your error so that you can get it. So the system is processing some here. This is the class name, right? And this class has two methods. One is the nest try, and other is the main. And as you know, when you will run this program, the execution will start from the main method, and when the execution will start from main, we are finding the length of the argument array A, and then it will run this statement, this one. This line will give you error if you are not passing any command line argument. In that case, the value of A will be 0. So if there is no command line argument, this line will create the exception. Otherwise, if you are passing some command line argument, then this line will run perfectly fine. Then you will get the value of A over here, and after that it will call nest try with A. The value of A is some value. Let's say if you have passed just one argument, in that case this nest try will get called. Nest try is the name of the method with the value of A that we are passing here. Because we are calling this nest try method inside the try, and this nest try has another try block. So that means this nest try method try block is nested inside the main try. So this try block that is there in the nest try, it is nested inside this because we are calling it within the main. So this is implicitly nested try because we are calling this method nest try method from the main method. So when there will be error in this try block in the nest try method, so let's say at this line when the value of A will be 1, so this will generate the error. So this will give you divide by 0 error. So when it will give you divide by 0 error, so the Java will create the arithmetic exception object for this line, and that object will be thrown. And when the object will be thrown, the matching catch block will be tested. So there is no matching catch block because this catch block is having the argument of type index out of bounds exception. So this is not matching for this. So when it is not matching, as we discussed in the previous slide, the catch block of the outer try will be checked then. So because here this catch is not matching, so the control will be passed on to the outer try block. So this is the outer try that is there in the main. So its catch block will be tested. So here we have catch block that can catch the exception that is generated here, arithmetic exception type over here in the nest try. So this will be passed on to this E object in the main, and you will get divided by zero exception. The concept is same. Whenever there is a exception that is generated in the inner try block, whether that inner try is physically there or it is created implicitly via the method call. So whenever the exception is generated inside the inner try, first of all, the catch blocks that are the part of the inner try block will be tested for a match. If none of the catch block of the inner try matches with the exception type, then that exception object is passed on to the outer try. Then the catch blocks of the outer try are tested for a match. If the match is found in case of the outer try, then that catch block gets executed. If the match is not there in the outer try also, then the exception object is passed on to the default exception handler. So this is the sequence of execution. I repeat, whenever the exception is created in the inner try block, first of all, the the catch blocks that are there with the inner attached with the inner try, those are tested for match. If none of the inner try catch block matches, then the Java tries to match find a match with the outer try catch blocks. If none of the outer try catch blocks also matches, then the exception object is passed on to the Java default exception handler, and it will be and your program will stop abruptly. So discussed before we discuss the next slide, so I would like to ask. Java supports two words that we are going to discuss in this slide and the coming slides. One keyword is throw and the other is throws. So earlier, before this slide, we discussed that inbuilt exceptions only. We discussed that whenever the exception arises in a Java program, Java creates object corresponding to the exception and throws it. But if you want to create your own exception class, or you want to throw the exception object yourself based on some business logic, then you can create the exception object and throw it using the throw keyword. So whenever you want to throw the exception yourself, or you can say that whenever you want to throw the exception explicitly, then you can use the throw statement. The format of the throw statement is first you will use the throw keyword, and then the throwable instance means here you will you will write the object that you want to throw. So you have to create the object of any inbuilt exception class, or you can create your own exception class and throw the object of that class. So we will discuss both of these cases. So the throwable instance can be a subclass of throwable class, right? Or it can be a user defined class or inbuilt class as well. So how the next slide is about this concept. So in this case, we have one class named through demo, and I would just like to show you the try block. This is the try block of this method demo procedure. I have drawn a boundary around this try catch block. So we are calling this demo procedure from the main within the try block over here, demo procedure. This is the name of the method. So when it will be called from main, the control will be transferred to this method. In other words, we can say that the Java will start executing the statements that are there in the demo procedure method. So the very first statement will run, and in this statement we are creating the object of one class, and the class name is null pointer exception. We are creating the object of this class and passing one string to this. So that means here, to create the object, as we discussed earlier, you will first write the new keyword and then the class name. Within the parenthesis, you will write any value that you want to pass to the constructor. So we are passing this demo string to the constructor of the null pointer exception class. So this will create an object that I'm going to draw a boundary around. This will create the object, and that object will be thrown by this throw keyword, right? So this throw keyword will throw. So when it will throw, as we discussed earlier, the two methods are there. One is when there is exception, Java will create the object implicitly and will throw it. Other method is you can use the coding to create the object, exception object, and throw it using the throw statement. So we are doing here the explicitly throwing the exceptions. This is the technique we are going to discuss. So this throw keyword will throw this exception object, and whenever the exception object is thrown, Java will find a matching catch block. So it will try with the catch blocks that are attached to the try block wherein the exception has generated. So it will try to find the catch block. So it will find a catch block over here with the matching argument null pointer exception. The object that you created with the new will be passed on to the e reference variable, and then the body of the catch will execute, and you will get this message on the screen, caught inside demo procedure. And then we are throwing the exception. So this throw keyword will again throw the exception object. So when this exception will be thrown, then it will find the matching block in the outer try block, right? Because this statement is there in the catch itself. So whenever you will throw the exception in the catch, the catch block are tested for matching. So the outer try is this, because this demo procedure is called within the try block of the main. So that means this try block of the main is the inner try block, and the try block that is the outer try block. Sorry, the try block that is in the main is the outer try block, and because we are calling the demo procedure within this try block, so that means the try catch block of demo procedure is the inner try block. So this inner try block catch statement is throwing the exception through this line, and when it will be thrown, the outer try catch block will be tested. So this means the exception that you are throwing here, let me point it with that you are throwing here, will be passed on to the catch blocks of the outer try, and outer try has one matching catch block. Null pointer exception is there, so this will catch this thrown object E, and then it will run the body of this, and you will get another message record, and the value of E will get printed. And whenever the value of E will get printed, you will get the toString method will be called, and the corresponding message will get printed on your screen. This is the case where you can throw the object using some business logic. So in this case, see, we are calling this validate from the main method. Validate is another method in the class, static type method. This one, when it will be called, we are passing it age. So if age is less than 18, we are creating one kind of object, and this time we are creating arithmetic exception object of arithmetic exception class, and passing not valid to the constructor of this class. So when the object will be created over here, it will be thrown, and because this object is not in the try block, right? So the exception object will be passed on to the Java default exception handler, and when the Java default exception handler will receive this exception object, it will display the information that is contained in this object on your screen, and your program will come to the end. And when your program will end through this line, that means the statement following the valid will not be executed. And if the age is here, from here you are passing a value greater than 18, let's say 20 over here, then this condition will become false, and you will get the message welcome to vote. And after finishing the execution of the validate method, the next statement will be executed, and you will get the rest of the code. But if you pass 13 to this method, the exception will be thrown, and that exception will be passed on to the Java default exception handler. So in that case, rest of the statements, this statement will not be executed, because when the Java default exception handler receives the exception, rest of the program is not executed, or we can say your program will terminate abruptly or abnormally. Now the second is the keyword throws. So when we should use it, that we are going to discuss. The first important point that is mentioned over here is if the method is capable of causing the exception that it doesn't handle. If so, the method is let's say generating the exception, but it's not handling that exception, then that we informs to the Java through the throws keyword. So if we have any method that is that can generate the exception, but that is not handling that exception itself, then we can intimate that to the Java by using the throws keyword. So here in such kind of method, but a method that, I repeat, a method that can create the exception, that is capable of generating the exception, but it's not handling it, in that case we use throws. So we have one method, we will write the method name over here, and then the return type of the method. There will be some parameter list as we discussed earlier, After the parameter list, you will write throws, and then the kind of exceptions that method can throw. So keep in mind, this we will use when the method is itself not handling the exception, right? But it can generate the exception. Only that we use the throws keyword. So after that, the body of the method you will write. So to make it more clear, let us discuss one example based on that. So here is the program, and this program as written over there contains an error. It will not compile, right? And if you the reason over here is when why it will not compile. The reason is this method is creating the exception through this line. It's throwing the exception. Why this? So it is capable of throwing the exception, but it's not informing to the Java compiler that or Java that it's incapable of this. So we haven't used throws over here. So that's why it's giving the error message. It will not compile. So how to sort out that problem is, in this case, in the throw demo, we have one method. Let's say throw1 is the name of the method, and it throws the illegal access exception. And here it's generating the exception. It's creating the exception. So we haven't used try catch block in this case. So it's not handling the exception itself. It will generate the exception and will throw it, right? So within the main, we have called this method throw one method. When the throw1 method will be called, uh, because this is generating the exception. So when the exception will be generated, it's not capable of handling it. Then it will be passed on to the try block over here, the main try block, and you will get the exception object that has thrown through this line in this parameter C, and the println will print that. So the next example based on the same concept is, here in this case we have one class test throws. In this one m method is there, this throws one exception. So again notice that this method is throwing the exception, but it is not handling it itself, right? So if it is not handling it itself, then that method should use the keyword throws to inform to the Java that this can generate the exception but not handling it. Another method is also there, this one n, and it also throws the IO exception in this case. So in the main, if we start from the main over here, we are creating the test throws class object. So this is the test throws class. We are creating its object. Then we are calling the p method of this class. So this is the p method. So in here in p method, we are calling n. So n is a method that is not handling the exception itself. So you have to, the method who is calling this method have to implement the try blocks. That's why this p we have implemented try block, because it's using the n method. is not handling the exception itself, but it is throwing it. So whenever you want that, you want to implement a method that can throw the exception, but you don't want to handle it in the method itself, then in a class where you are using that method, where you are calling that method, you have to keep the call of that method in the try catch block. So that's why we have kept the call of and in the try catch, because this method throws the exception. So when it will be called and, so here it will call so in we are basically creating the exception, so it will throw it. So that exception in fact, this n is also throwing the same exception, and then it will be passed to the catch block of the piece try. This will handle this exception and will print the message exception handled. So then comes the last keyword of the try catch exception handling using try catch. Last keyword, fifth keyword, that is finally. So in case of finally, if we use this word, the finally block is executed uh, whether the exception is generated in the try block or not. So irrespective of whether the exception is generated or not, the finally block will get executed. So it will get executed always. So this is the first case. Second is the finally should be written in the as the last block of the try catch, and this will not have any parameter. So I'm going to show you the example directly to make it more clear. So in this we have one class final demo, and in final demo we have one method procedure A, and in procedure A we have one try block. If you attach a try block finally with a try block, then the catch becomes optional. Right? You can write the catch block or you can skip that. So in this case we have used the try block, and with this try we have used directly the finally block. So the finally block will be executed always whether there is the exception or not. Then we have one procedure B, and in this we have a try block and finally. So again we don't have the catch block in this case. Then third procedure is there with third try. This is the finally block and try block, and in the main we are calling the procedure A. So when you will call the procedure A, this will get called this procedure. It is the case of the nested try, because we are calling the procedure inside the try block. So in procedure A again there is a try block. So this is the example of the nested try also. So when this procedure A will run, it will give you this message inside procedure A. Then it will create the exception, new runtime exception. So when it will create the exception will be thrown. So when that exception is thrown, basically, then it will try to find out the matching catch block. So catch block is not there. So there is only the finally block. So what will happen in this case if you write the finally block? Because it's not finding the catch block, so the finally will get executed. So you will get the is finally answer. So here I would like to show you these points once again to make the statements more clear. So the first important point is it finally creates a block of code that will be executed after a try catch block has completed and before the code following the try catch block. So it will get executed before the code following the try catch block and after the try catch. Then the second important point is finally block will execute whether or not an exception is thrown. This is the second important point. Third is if exception is thrown, the finally block will execute even if no catch statement matches the exception. So if there is no matching catch statement, in that case also the finally block will be executed. And the last point is at any time a method is about to return to the caller from inside a try catch block via on card exception or an explicit return statement, finally clause is also executed just before the method returns. So here, this is the important point because if you look at this slide, when the exception will be thrown, because there is no catch block and the method will return to the main, and before the method returns, according to the last point we discussed over here, before the method returns, the finally gets executed. So this will get executed. So you will get the procedure is finally, and similarly when this will be called procedure B, so you will get this message inside procedure B, and before the method returns you will get the procedure B is finally as well. Then the C will be called procedure C. You will, when it will be executed, you will get inside procedure C, and before the controls goes back to the main method again, you will get this method also procedure B is finally. So this will be the output of this program, and there are some inbuilt exceptions on in the Java that I have shown through this slide. One is arithmetic exception, then array index out of bounds exception. The next is array store exception. Many more are there. I have listed already a few inbuilt Java exceptions. So if you have any